Hello again, guys, and welcome back to the Engineering Principles course on Learn.io. Today we're going to be learning about force as part of our simple physics unit. So according to Webster Dictionary, force is defined as strength or energy exerted or brought to bear, or the cause of motion or change. So the first definition is a little strange, a little harder to understand, but I like the second one quite a lot. The cause of motion or change, because it does actually explain force very well. Force is something that causes an object to move or accelerate. And you can see this in Newton's second law. And I'll just warn you that what I have written here is not the actual wording of the law. The law itself is rather long and it's a bit more specific than this, but physicists have simplified it down to this equation, which once you get into high school physics, this is really it's the bread and butter of physics. It's something that you'll use the entire year. And basically, it's that the net force acting on an object will always be equal to the object's mass times the object's acceleration. And we have that here written as sigma F equals ma. The little E looking thing is sigma, which is a Greek letter. So in this equation, sigma F stands for actually net force, not just force. Slight oversight. M stands for mass, and A stands for the acceleration of the object. So to apply this and understand this a little better, let's try an example up here. We have an example of a man that pushes a box with a mass of 5 kilograms so that it accelerates at 2 meters per second squared. Remember, acceleration is meters per second, so it's meters per second squared, whereas velocity would just be meters per second. The question's asking us how much force he's applying. So in physics, whenever you tackle a problem that has forces involved, you always want to start by drawing what we call a free body diagram. That's basically this thing we see right here. What you do is you basically centralize all of the mass in your system into one circle that we have right here, and draw arrows that represent all of the forces acting on the object. So any object that's on Earth, and we can assume that he's on Earth, will always be experiencing the force of gravity, pointing straight down towards the center of the Earth. But what prevents us, if there's always this force of gravity pulling us down, what stops us from just falling straight down? Well, it's called the normal force. It's the force of the Earth pushing against us in an upwards direction. Now that actually follows similarly to Newton's third law, but we won't really be getting into that right now. We know, though, that the force of gravity always has to equal the normal force, because if there was a net force, if one of the two forces was greater, then there would be a net force in the vertical direction, which would mean that there would have to be an acceleration in the vertical direction. We know that in this situation there's no vertical acceleration since it's just moving 2 meters per second squared to the right. So those two forces must cancel out. So we can just draw a little line through these two arrows, and that's not to cross them out or anything, that's just signifying that those two vectors have the same magnitude. They're of the same size. So then we can go on to the last force that we know is acting on this box. It's the FA, or the force applied by the person. So since this is our situation and we're just worrying about FA, we can use the equation sigma F x equals m, which is 5, times a, which is 2. So we know that the net force acting in the x direction on this box equals 10, that was a bad zero, meters, or sorry, 10 kilograms, it's going to be rough, meters per second squared. One more thing to know is that this right here, kilograms meters per second squared, is what newtons are. So force is measured in a unit called newtons, named, of course, after Sir Isaac Newton, who was an incredibly important mathematician and physicist. So that actually equals 10 newtons of force right there. So hopefully that helps you understand forces and how they work a little better and gives you a brief introduction to how to actually find force. Of course, you can rearrange this equation if you know what the force is that's acting on the box in order to solve for acceleration or mass, and that is sometimes what problems will ask you to do. But hopefully this already gives you just a basic understanding that you can take into the future lessons. Thank you. Hey, so after I finished the last recording, I just realized that I forgot to explain something real fast about what we do when we analyze the motion of an object. So in physics, whenever we're analyzing the motion of any object, be it the box that's accelerating, be it a car that's slowing down, or if it's just somebody running at a constant speed, we always want to break down its motion into its x component and its y component. So x being horizontal and y being vertical. This is because it's easier to do the math for one, and also because the x motion or the horizontal motion tends to be independent of the vertical motion. So that's why in this example we used fx and not just sigma f overall, and that's why we didn't include Fn or Fg, the normal force or the force of gravity, in our equation, because we are just concerned with his horizontal motion. We broke apart the motion into horizontal and vertical, which just made the equation much easier to work with. So again, sorry about not mentioning that while I was doing the video, but hopefully that helps clear up any misunderstanding that might have occurred. Thank you.